Okay, ji. Assalamualaikum everyone. This is me. This is October November 2025, and the variant is 53. Let's begin solving. Question number one says there are a large number of students at Greenfield. Each student travels to college by car, by foot, bus, or foot, independently of any other student. The probability that any student travels by car is zero point 0.4. The probability that any student travels by bus is 0.35. Three students from Greenfield College are selected at random. That none of the three students. So this is just a simple binomial question, I think. I'm going to say probability of 0 is 3c0, q power 3 minus 0, and p power 0. Okay, so I will get point, or let's just write this in fractions, 27 over 125. Okay, easy one mark. 11 students from Greenfield College are selected at random. Find the probability that fewer than 9 of these 11 students travel to college by bus or by car or by bus. Okay, so now 11, but my success is different. My success is now 0.75. Okay. Fewer than 9 means that I want to calculate the probabilities of 0, 1, 2, 3, up till 8. Okay. So what I'm going to do is I'm going to subtract 9, 10, and 11 from 1. I will have to write these expressions. I will write 11c9, q power 2, 0.75 power 9, 11c10, and 11c11 power 11. Okay, let's do this on our calculator. 0.545. Okay, easy first two questions. There's this, the splash has 26 members, of whom 16 are swimmers, 10 are divers. No member is both a swimmer and a diver. The club committee consists of 6 of these 26 members. In how many ways can the club committee be selected? So this is about combinations for now. If it must include at least 2 swimmers and at least 2 drivers. So swimmers and divers. There are 16 and 10. What are the cases then I could come up with is that at least 2 swimmers and at least 2 divers. So 2 swimmers and 4 divers, because I need a total of 6 people. Then I can have 3 and 3, and I can have 4 and 2. Okay, I don't think there are any other cases possible. So I'm going to say 16c2 into 10c4 plus 16c3 into 10c3 plus 16c4 into 10c2. Okay, let's check if we have all the cases. Yes, I think we have all the cases. Let's calculate. This one comes out as 25 200. I think that's the right one. Let's do this on my calculator. 16c 2 into 10c4, 25 200. Yeah. 67 200. 81 9. So total I get is 174300. Okay. Okay. Then question number 3 is about permutations. It says find the number of different arrangements of the nine letters in the word daffodils. So I'm going to first write daffodils in this format, in which there is a D at each end and the two F's are not next to each other. So D at the end, D at the end, and 1, 2, 3, 4, 5. 1, 2, 5. Those are all the other letters. So first I'm going to arrange all these other letters. Are there any repeating? No, there are no repeating. So 5 factorial. Where can the daffodils come up? The daffodils can come up in this space, here, here, here. Oh, sorry. The F's can come up here, here, here. How many are there? 6. So I'm going to say that the F's are going to be 6C2. Arrange them, then divide them. Okay, so that's 5 factorial into 6 to 120 basically. That gives me 1800. Okay, again, an easy question. Find the probability. So there has to be a denominator then. That the chosen arrangement of the 9 letters of the daffodils has exactly 4 letters between the two. The first, the denominator, so 9 factorial divided by 2 factorial into 2 factorial. Okay, what about the numerator? For the numerator, what I'm going to do is I'm going to say that there's a D, and there are 4 letters. D, how many do there have to be in total? 4, 2, 6, 7, 8, 9. How many cases? Let's see. Okay, those are the cases. Each case will be 7 factorial over 2 factorial. Okay, so what is the numerator? The numerator is then 4 into 7 factorial divided by 2 factorial. And what is the denominator? The denominator is 9 factorial over 2 factorial. Okay, I think those should be the cases. 4 into 7 factorial. So I'm getting 10080 over 9 factorial divided by 4. 9072. 1009072. 1 over 9. Yep, that is the correct answer. I think all of these are pretty much repeated questions that are easy. We are quickly on to question number 4. A fair red spinner has 4 sides numbered 1, 2, 3, 4. A fair blue spinner has 4 sides numbered 0, 1, 2, 0, 1, 2, 3. When a spinner is spun, the score is the number on the side on which it lands. These two spinners are spun at the same time. The higher of the two scores obtained. If the two scores are equal, then the value of x equals to 0. So whenever you have two scores and you need to put them together, what you should do is should make a possibility diagram. Okay. So higher of the two scores. So 1, 0, 2, and 3. Those are values for x. 2, 2, 0, and 3. 0, 4, 4, 4. Yeah, I think I have these numbers. Okay, so probability distribution table for x and probability of x. What are the possibilities? 0, 1, 2, 3, 4. Okay, what is the probability of 0? 3 out of 16. What is the probability of 2? Also 3 out of 16. Sorry. What's the probability for 1 out of 16, 5 out of 16, 4 out of 16. Okay, I think we have all the numbers. Let's verify if our probabilities are correct. They are all correct. Let's move on and see. Find variance of x. Variance of x is simple. Variance of x is sum of x squared p minus, I don't even have the mean squared, but I'm going to calculate this. Oh, the first x was 0, probability 3 over 16. Then the second x was 1 over 6. Then 2 square into 3 over 6 plus 3 square 5 over 6 plus 4 square into 4 over 16. That's this. For the mean, I'm going to do a separate calculation. I'm going to say x bar is sum of x p, that's 0 into 3 over 6 plus 1 into 1 plus 3 into 5 over 16 plus 4 into 1 over 6 plus 6 over 16 plus 15 over 6 plus 16. So 19 over, which is 2.375. Okay, so let's calculate this. Then 1 over 16 plus, so 1 over 16 plus 12 over plus 45 over 6 plus 64 over 61 over 8 is 2.5. The exhausting part of these questions. Or okay, that's the variance of x. I don't know if you can round off or you can exact. Okay, the red spinner with sides numbered 1, 2, 3, 4 is spun repeatedly. Find the probability that it lands on the first time. So first time means it's a geometric now. And my success is 1 out of 4. Before the 8th spin. So before the 8th spin is 1 minus q power r minus 1. So 1 minus 0.75 power 7. 0.87. Okay, easy question again. Question number 5. Jen has 3 boxes. Box A contains 5 counters, of which 3 are white and 2 are yellow. Box W contains 4 red marbles and 3 blue marbles, 5 red marbles and 3 boxes. Then chooses one counter at random from box A. If the counter is white, he chooses 2 marbles from box W at random and without replacement. If the counter is yellow, he chooses 2 marbles from box Y at random and without replacement. Draw a fully labeled tree diagram to illustrate this. Information includes probabilities. Let's start in the middle. Let's first talk about box X. Make it wider so that then have a good division. So this is box A. I can have white or I can have yellow. White or 3 out of 5 and 2 out. Okay. So if the counter is white, he chooses 2 marbles from box W. So box W. And box W has the red marbles and blue marbles. Then you have box Y, red and blue. I'm going to now fill up the probabilities. Okay, now filling up the probabilities. Box W contains 4 red and 3 blue. So 4 out of 7, 3 out of 7, 4 out of 6, 3 out of 6, 3 out of 6. Okay, then 5 and 3, 5 over 8, 3 over 8, 2 over 7, 7, 4 over 8, 4 over 7, and okay. Yeah, I think that sounds about correct. Then it says draw a fully labeled tree diagram to illustrate this information. All the probabilities. What I have a habit of doing is I also write down the outcomes because I know that it's going to help me in the next step. So WBR, WB, YRR, YRB, and YB, YBR, sorry, or YB. Okay. Find the probability that one red marble and one blue marble are obtained. One red and one blue. So which ones am I talking about? One red and one blue is here, 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 here. So I have to add a 4 branches. 3 over 5, 4 over 7, 3 over 5, 4 over 7. That's the first one. Plus 3 over 5, 3 over 7, and 4 over 6, 3 over 7, plus. Then I have 2 over 5, 5 over 5, 5 over 3 over 7, plus 2 over 5, 3 over 8, and 5 over 6. Okay, so let's add all of them up. 3 into 4 gives 36. 5 into 7 gives me 10, plus 36 over 10, plus 5 into 30, 5 into 8, 280. Okay, so 2 times 72 over 10 plus 60, 39 over 70. Okay, that is my final answer. Okay, moving on. Find the probability that a white counter is chosen from box A, given that. So given that tells me it's a conditional probability. What is the given that? One red marble and one blue marbles. One red and one blue. So that's the condition that I have above. So I'm just going to write that in the numerator. 39 over 70. What is the condition that I want in the numerator? White counter is chosen. Okay. So basically white, red, and blue. So what is white, red, and blue? Or white, blue, and red? Or white, red, and blue. Okay. So I think the first two that I wrote down for you, that was 36 over 210. So 36 over 210 plus 36. So 72 over 210 divided by 39. 8 over 13. Okay, I think that's an easy question. Yeah. Okay. Moving on, question number 6. Last Saturday, a cycling competition for teams of 11 cyclists took place. For each cyclist, the time taken to complete the course was recorded to the nearest minute. The times taken by the cyclists from the two teams, the linnets and the puffins, are shown in the table. Draw back-to-back stem and leaf diagram to represent this with linnets on the left-hand side. Okay, linnets and puffins. You can't mess up the order, and I've told you because they are forcing you to follow that order. Okay, so the minimum is 4, 5, 6, 7. Okay, so let's figure out the puffins first because I have a habit of filling out the right hand side first. So starting with 4, I have 45 and 49, 5 and 9. Then I have 1, 5, 5, 8, 9. 1, 5, 5, 8. Okay, then 2, 4, 4, 4, 4, and 4. Okay, then for linnets, that's 48. And then 1, 4, 7, 9. 1, 4, 7, 9. 0, 4, 4, 5, 8. 0, 4, 4, 5, 8. The interesting thing is that this is already arranged in order, so it's easy for me. What I need to do still is to make a key. So 0 slash 6 slash 2 means 60 minutes for linnets and 62 minutes for puffins. Okay, find the interquartile range of the times taken by the linnets. So that's for the lower quartile, you do 1/4 of n plus 1 h. So 1/4 of how many times are we talking about? We're talking 11. 11 plus h. That's the 12th. Third value. What is the third value? Third value is for the linnets. 1, 2, 3, 54. Upper quartile is 3/4 of n plus 1 t. That's the ninth value. What is the ninth value? Fourth, fifth, sixth, seventh, eighth, ninth. That's 65. Interquartile, 65 minus 54, I think 11. Okay, let's check if our answer is correct. Our answers are correct. This is on the diagram, draw box and whiskers plot to represent the information for linnets and puffins. I don't think they've provided you anything for puffins. We'll have to calculate that. Okay, let's first calculate for puffins. 1/4 of 11 plus 1 th gives you the third. The third is P1 for this one. 3/4 of 11 plus 1 th. Ninth, ninth, 5, 9, 64. The medians. Median for puffins. What is the median for puffins? Median for puffins is the half of 11 plus 1 th. So that's the sixth value. 1, 2, 3, 4, 5, 6, 8. Okay. And I don't think this asked for the median, but I'm going to calculate it here only to say that I want to use it later on. 1, 2, 3, 5, 6, 60. Okay, So I have a minimum of 45 and a high of 74. 45, 50, 55, 65, 70, 75, 80. Okay, so let's first draw one of these so that we don't end up being confused. Let's draw first the lineages. So 48 and 70 is minimum maximum. So 48, 70 maximum, 48, 70. Then the median, the quartile is at 54 and 65. So 54, 65. And their median was at 60. Okay. What I personally suggest is that also label the values that you plotted, lower quartile, upper quartile. Okay. Then for the other one, you have 50, highest 45 and 75 and 45, 70. Okay. 51, 64, 1. Puffins. And okay. Make one comparison between the times taken by linnets and puffins. So puffins had generally had lower times, or puffins had a wider spread. Puffins had wider spread. Puffins time were then times for linnets. Okay. Let's see what the comparison here is. It says acceptable comment about spread and central tendency, so I've done that. You can also compare the median. Okay, moving on. Question number 7. The times taken by Obi to walk each morning are normally distributed with mean 14.8 and standard deviation 1.5. Obi takes more than 15.6. So more than 15.6 means I just have to find this probability over root 1.5. I'm getting z greater than 0.53. Make sure that I'm not making an error. Calculate 0.533, 0.5. Table, have the table open, table quickly. 0.537 0.7029. So 0.2971 rounds off to 2 point finally. On 90% of the time, OB takes more than T minutes to walk to work. More than T minutes on 90% days. So Z greater than T minus again 14.8 divided by 1.5. 0.8 divided by 1.5 equals 2.9. So 1 minus 5T minus 14.8 over 0.9. 1 minus 0.9 to 5 of T minus 0.8 over 1.5. So 0.1. Okay, I have this habit of doing everything on the middle of the paper. Phi inverse of zero point 0.1 minus 0.85. Okay, looking up phi inverse here is not possible. So when you have such a situation, you instead look for its complementary number. So that's zero point 0.9 because they together make 1. So I'm going to read this number, but I'm going to put a negative with it. Okay, let's calculate then if we have the correct answer. P equals to 12.877. Three significant figures should give you 12.9 minutes. Okay, T is 12.9. Then it says OB walks to work 5 days a week for 45 weeks in a year. On how many days in a year would you expect OB to take within 1 minute of the mean time to walk to work? So, how many days would you expect? So, that's a lot of days. 5 days a week for 45 weeks. 45 into 5, that's 225. I first want to calculate the probability of within 1 minute of the mean time. What's the mean time? The mean time is 14.8. So within 1 minute simply means 13.8 T and 15.8. Converting both to Z values. 13.8 minus by 1.5. So minus 0.667 and 0.667. 5.667 minus. Okay, reading this from the table then 0.667. 7477. 7477. 0.4954. So the final answer is 0.495. That brings us to the end of this exam. I think a relatively easy exam, and the threshold should be high.